Thank you all for coming to MIX. We hope that you're enjoying yourselves. I hope the casinos haven't taken all your money yet. I'm here today to talk to you about delivering media on the web. Before we start, could I please get a quick show of hands? How many people deliver media from their websites today? Great. For those of you who don't, how many of you have thought about it? Awesome. Traditionally, we've had two major approaches for delivering media: progressive download and streaming. What I'd like to show you is a third option we're making available that we call smooth streaming. But before we dive into the technology and how smooth streaming works, what I really want to do is highlight the user experience, because that's the first thing that your users will see. So as the video loads, I'd like you to think about the last time you watched video online. How long did it take for your video to start up?
I always knew that I liked this plane. You don't have to look too far.
I cannot compete with Bon Jovi, so I'm going to pause it here. Like many web users, I have a very short attention span. So I've watched 10 seconds of this clip. I realized, nah, this is not quite what I'm looking for. So I want to watch something else. The last time you watched a video online and you found yourself in the same position, think about how long it took for the experience to start delivering that next clip. So what I'd like to really talk about today is how to enable you to have that kind of experience. What are the different approaches? What are the trade-offs? And actually, how to get it up and running from start to finish. A little bit of background about me. My name is John Bacharov. I'm a program manager on the IIS Media Services team. And I'd like to talk about some challenges that we all face in terms of delivering media online. First off, many of us already have existing content. So how do you get the most out of it? How do you deliver that content in the best way possible for your site? The next challenge is one that we call the last mile. And ultimately, you can set up all of these great infrastructures. There are many things that are within your control. But one thing that is not within your control is, what is the connection between the last server that your media will go through and the user, whether they're in the home or in the enterprise? What are the capabilities of that connection? And what are the capabilities of the hardware on which they'll be playing the video? It may be a set-top box. It may be the latest and greatest PC that has just come out. It may be a netbook. So how do you address all of the space of possibilities there well? Once we've gotten the site up and running, we've found a way to address that challenge, we've given our users that experience, how do we make money? And how do we scale to a growing audience? And I'd like to conclude today by showing how to bring an end-to-end solution to life. So let's get started. At the keynote, Scott Guthrie announced a new product called IIS Media Services. And really, it's about being able to deliver media and web content from the same server. And what we'd like to get your feedback on today is whether or not what we're trying to do really aligns with your needs, how well the product you see does what its stated goals are, and how we can make it better. So the first thing that we'd like to do with this product is to create a user experience that scales very smoothly from a very small capability device, like a set-top box or a mobile or maybe a netbook, all the way up to those users who have the connection and they have the processing power to render true HD. So give the users the best quality they can actually handle. That's one of our goals. The next goal we have is to provide you a platform that actually allows you to make money. That means making sure that you make the most from your advertising if you are ad-funded, or from subscriptions if you use a subscription model, and also making sure that the costs stay down. And finally, it's really about scale. Can the technology scale from the challenge of, I have a small site and I want to reach a fairly modest user base, all the way out to, I have the blockbuster event and I want to reach every user with a web browser? So those are our three goals. And really, I would love to hear your feedback on how well this product aligns with those goals and how well the goals aligned to what it is that you need to do with your sites. What are some of our motivations in terms of using a product like this or in terms of delivering media? Well, these are all things we can get behind. We want to drive more traffic to our sites, and we want to increase our revenue. In many cases, that revenue comes from ads, right? How can media help us do this? First off, you create this really great, rich, engaging experience that keeps your viewers watching. So the number of hours they spend or minutes on your site goes up. Secondly, video ads just pay better. So those are two ways in which media can help us. Now, it sounds like most of you already use media or think about it using media, so this is certainly no surprise to you. The next reason of why you might choose one product over the other is what gives my users the best playback experience. What we would like to enable people to do is to make HD on the web a reality. To make sure that, like the experience we saw at the beginning, your users never wait for their content. When they want to start, it starts. When they decide they want to watch it at 3 minutes, 5 minutes, it seeks. When they want to watch a different clip, it just loads. And the way that that happens is by delivering the right bits at the right time. And finally, what does the platform provide to help you make money and to help you scale out? How much custom code do you need to write to integrate with an analytics provider? How much custom code do you need in order to be able to track what your users are doing at any point in time? And finally, how much effort does it take to scale out to a growing audience? Let's talk about the various methods. So I've mentioned before the two main methods that have been available are progressive download and traditional streaming. We're talking a lot about smooth streaming, which is this new method we've developed. But let's focus for a moment on progressive download. Easy as pie. You have a server. You throw some content on that server. The client asks for the content the way they would any other piece of HTTP traffic. Your HTML page, your JPG, the server does not care. I have a file, download it, right? So the client, we've all seen a download progress bar exactly the same way that progressive download works. By the time that you've received enough content to play it, the player will start playing. That's where the progressive comes from. You don't need the whole thing. You can play based on what you've already downloaded. How can we make existing content delivery better? Well, there are a couple of challenges, and I'd like to talk about a couple of features that we have in media services that are designed to solve those challenges. The first challenge is use of bandwidth. A typical pattern for using progressive download content is open up the video, let it download. If you've got a good connection, and especially if the video is encoded at a fairly low bit rate, common denominator maybe 500 kilobits, 700 kilobits, with a great connection in a couple of seconds, you've downloaded everything. You've watched 20% of the video, you said, I don't like it. This is a typical pattern. That other 80% is wasted bandwidth. As a website owner, as a content provider, you've paid for that bandwidth, you've gotten no benefit out of it. Neither has your user. So how do we stop that? Secondly, once we have that content, how do we make sure that it is consumed in a way that follows our business rules? If we have an ad-funded model, very typical pattern. You show a pre-roll advertisement, then you show the premium content. What you want to do is keep clever users from posting a link to the premium content that bypasses the ads on a forum. How can the platform help you do that? So that's the motivation for a feature we call web playlists. And finally, if you have existing Windows media and you want to stream it online, Windows Media Services is a great option for doing that. So with that, I'd like to show how some of this stuff works. This user interface is the Internet Information Services Manager. And for those of you who may be seeing this for the first time, it basically is organized into three panes. First, on the left-hand side, you have a hierarchical representation of all the content on your site. We'll be using this quite a lot today. In the middle area, it shows for the node that you've selected. So in this case, I'm looking for the origin. This is where the root of my content. This is the authoritative copy of my content. For the origin, in this case, it's contextual. What are all the various features I can consider? What are the various parameters, and how do you change those settings? There's another view for the center pane that actually will show you the content on the file system. On the right-hand side, also depending upon where I am in the hierarchy, depending upon where I am in the feature settings, we have a set of contextual menus. So in this case, some of the natural actions might be I'm looking at the website to restart it, to change its settings, to change its bindings, etc. So with this in mind, we're going to go to the origin server. And in this case, I have a virtual directory that points to content. And this is my existing progressive download content. And we're going to go to the center pane and open up the content view. And we can see here that in addition to a couple of minor files, we have two presentations. One is an advertisement, and one is actually presentation.wmv is one of the media talks from MIX last year. So we're going to talk about how to deliver that. So here's a link to the content. Right now, I have not enabled bitrate throttling. So if I go download this content, I'm just going to say save target as here. And doesn't matter where. Yes, overwrite it. And so it's come down pretty quickly. I've got a great connection. The content is encoded at a great bitrate. In about 3 seconds, I've got it. Right? Now, if I actually watch that presentation and I decide 5 minutes in it's not for me, I've just wasted a whole bunch of bandwidth. So what we're going to do is we're going to come back to the IIS UI and put the center pane back into features view. And then under media services, we have a feature called bitrate throttling. So just going to open up bitrate throttling and enable it. And enable is in the right-hand side here. So we've enabled bitrate throttling. What you see here is actually the default list of configured file types. So for all of these file types, this is not just for WMV. If you drop the content onto your server, bitrate throttling will detect what is the encoded bitrate of the content and exercise rules based upon that encoded bitrate. So you can see here it's got a couple of configurable parameters. The first is fast start. Fast start basically says, even though I'm throttling the content, I want to make sure that playback starts immediately. Typical media file has a whole bunch of metadata at the beginning. I want to give that metadata to the user as quickly as possible so that even if the content is throttled, that playback experience starts immediately. And then the next parameter, throttle rate, specifies at what percentage of the encoded bitrate as detected, as coded in the file, do I want to deliver the content. So in this case, I've just enabled this feature, and I'm going to come back to my content. And I'm going to download this file again, now with bitrate throttling enabled. So what you see here immediately is that we've bursted the first 20 seconds, and now bitrate throttling will deliver the content as fast as it's encoded. So if the user watches the first 5, 10 seconds, realizes this isn't for them, you haven't downloaded the whole thing. You've only downloaded that beginning part that they've watched. So this is just a great way to save bandwidth for progressive download. Next, let's come back to our rules. So we've said, when we looked at the content, we have really what we want to do is this presentation represents a premium asset, and we want to find a way to monetize it. And the way we monetize it is we have a pre-roll advertisement, and that pre-roll advertisement must be played before the premium content is available. So I'm going to go back into features view for this content, and I'm going to select web playlists. What I've created here is a fairly simple playlist. Let's open up WP ad funded. I've created a fairly simple playlist that contains the two presentations. So one thing to note is that in many cases when you use web playlists, your content isn't HTTP visible. The whole point of this is to not let people download the things if they don't follow your rules. So what we've done here is we've used a physical path, and we've said we're going to define this entry point, an ISX entry point, that's the extension of the playlist, that will let you download the content we've defined. And we've set a couple of rules. So in this case, what we've basically said is this first piece you can't skip, you can't seek, and for the premium content, go ahead and seek into it. So we can come over here and take a look at what this looks like to a user. So I'm just going to copy the URL of the playlist and paste it into this test player and see what we get. So the first thing that plays is an advertisement, right? I cannot seek or skip. This player is enforcing that behavior. And now Once the advertisement is done, the presentation actually begins. So I'd like to give you guys just a little bit of insight into how this actually works. So when we have this file, what comes down to the user is a playlist. This playlist is in the ASX format, and it is viewable by Windows Media Player. It is viewable by Silverlight. A lot of different players understand what this thing looks like. So we're just going to look at it here with Notepad. Okay, so something very interesting has happened. Instead of having the two pieces of content that I've encoded, what I've gotten as entries in the playlist are obfuscated URLs. So you can take a look here, and in this case, what we've done is all the content is always consumed through this ISX entry point, but the server has made up a unique session ID for my session. So in this case, if I were to do this exercise again, start another session, the server would make up another GUID. And now the server is going to actually enforce rules based on whether or not I am consuming the content in the order it was intended, right? So I'm going to pretend to be a user who isn't following the rules, and I'm going to say, just give me the premium content. So I'm going to take this URL. I'm going to copy it right into my web browser. And it says denied. Why? You haven't downloaded the ad. You're not following the rules. So this is just a really simple way to get enforcement of the business rules that you want enforced in your application. So now that we've talked a little bit about progressive download and how to get it better, let's talk about the various methods once again and what are the benefits of each one. So we have to make this choice. With traditional streaming, there are some things that we really like about it. The first is we get a great responsive user experience. When the user says play, pause, seek, the server responds, you get your data. You get very good use of bandwidth. The server sends only what the user intends to watch. And finally, because the server is actually tracking what the user is doing, you have a very good sense of what it is that the user did and what their experience was like. The challenges with the streaming network have to do with scale. So as we look at traditional streaming, we'll see in a moment that really the challenge with traditional streaming is getting it to scale out. Progressive download, which we just looked at, also has some really great advantages. The first is, if you have an existing web server today, you can throw your content on it and you can do progressive download. Easy as pie, simple, no media server required. The other thing is that progressive download is aligned to the way that the HTTP web works. So Alex Zambelli presented an overview of the media ecosystem, and he has a phenomenal quote that is so good I'm going to steal it from him. And what Alex says is that we used to try to create networks that would try to adapt the web for streaming. What we need to be doing is adapting streaming to the web. So what we'd like to do is find a way to get the best of those benefits. And to that end, we've created smooth streaming, which is designed to combine the best advantages of each. So let's contrast on a technical level how this works. So we've talked about progressive download. You throw it on a server. You just get a download the way you would any other file. Traditional streaming. In traditional streaming, the client sends the server instructions like play, pause, seek. And based on those instructions, the server sends a stream of media packets. These packets are typically very small. They may be 1 or 2 kilobytes in length. And the other thing to note is that the packets are tailored for a client. So this is a stateful protocol. The server keeps track of who you are, the server keeps a session for you, and the server will send packets that are designed for you. That has some great things, that has some downsides. Let's talk about how smooth streaming actually works from a technical standpoint. So in this case, the client, instead of saying, I want the entire file, makes a standard HTTP request. But that request is for a particular piece of the media. So what we've done is we've thought about the movie not as a long continuous sequence, but as a set of fragments, as you can see on the left-hand side, that are fragmented along natural boundaries. And what the client will do is it will say, I want you to give me a piece of this movie as this natural fragment. So it might say, give me the video at 1 minute and 4 seconds. And the server is going to pull out that fragment from the video and return it as what looks like just an HTTP object. Now, the interesting thing about that is that if we have an edge server in between, this is a web cache. It knows nothing about streaming. All it does is it caches HTTP traffic. I see a URL. I see a response. There's a header that tells me I can cache this response and how long to cache it for, so I'm going to persist it on disk. And so as that packet goes by, any HTTP cache that happens to be in the flow is going to retain a copy. So we've sent the packet to the client, the fragment. It's about 2 seconds of video is a typical value we use. And we've retained a copy on the edge server. Now the client will ask for the next fragment as it's playing back. So it might say, give me the video at 1 minute and 6 seconds now instead of 4. And the server will do the exact same thing. It pulls out the appropriate fragment. It lets the HTTP cache in between cache it and sends it to the client, so on and so forth. As the operation progresses, the client just keeps asking for fragment after fragment. Now, the great thing about this is that if you have another client who wants to do the same session, I want to play the same movie. What it does is it makes the same set of requests. Because instead of asking for arbitrary fragments of this video, we've defined what the boundaries are. And when it makes a set of requests, the cache has already seen those requests, and it has cached the responses. So it can just deliver the responses directly from disk without needing to contact the server. So what we've done here is we've taken advantage of a cache that knows nothing about media, knows nothing about smooth streaming, and knows nothing about how the overall flow works. It just thinks URL response, I've cached it. Great. So that solves part of the problem. That doesn't solve the whole problem. The challenge that we need to address is what I call the last mile. And really, we have many different types of clients. Some clients are in the following situation. They have a great CPU, so you've got latest and greatest hardware, but you have a very slow link. In that case, the optimal experience for that client is, give me the best quality I can download. Another type of client, so maybe this is somebody running around with a netbook. You've got a great connection, but you're limited in terms of what you can decode and render. So the best experience we can do for that client is, give me the best quality I can actually render. And finally, you have somebody who's got the latest and greatest hardware, and they've got a great connection. And what you really need to do for them is give them the best quality, period. So there are some approaches to being able to handle this problem as written. But the real challenge of the last mile is it's not just a matter of classifying users. Because a user that started out in one category, 2 seconds later can be in another category. You had great bandwidth. Now you're downloading something else in the background. Your bandwidth has gone down. You had great CPU. You're running an AV scan, antivirus. You're indexing the file system, whatever. Suddenly your rendering performance has gone down. So to address the last mile effectively, we really need to be able to make the choice in real time. Not just make it once and have the user be stuck with it, but make the choice in real time. So to that end, on top of this fragmented smooth streaming delivery, we've layered the concept of multiple bit rates. So in this case, the video is still fragmented along natural boundaries. In this case, the boundaries are every 2 seconds, once again, a typical value. And you lay down on the server a set of files that represent the same presentation at different quality levels or bit rates. So in a typical low value is 300 kilobits. So if somebody has a really bad connection, we want to make sure that their video just plays forward. So we encode a version at 300 kilobits. At the top of the range, you might have something like 720p True HD, 2.4 megabits, 3 megabits for really challenging content. And you will choose a number of layers in between. James Clark did a session earlier. I would encourage you to go look at the recording about how to make this decision to get the best delivery possible. But in a typical scenario like this, you would have about 4 layers in between. And now, the client, in addition to simply requesting one fragment at a time, also runs a component that we call the bitrate heuristics. And this component's job is to determine what is the bitrate I should be giving you. When we looked at the experience, one of the things that we wanted to do with it was have it to start immediately. So to do that, we will typically request a very low bitrate to make sure that you get that content as quickly as possible, even faster than real time, because that is the amount of time the user has to wait. So we've requested the lowest bitrate to make sure, let's start immediately. And this client then issues a request that is, give me the fragment of video that's at 300 kilobits at the beginning of the presentation. The server will then find that fragment and deliver it. Now the bitrate heuristics come in again. They look at what has just happened. They look at, I wanted to download this fragment, and ideally I would download it even faster than real time. How quickly did I actually get it? Based on that very empirical calculation, it's going to make another decision. It's going to say, I think your network's pretty good. That was 2 seconds of video. I downloaded it in half a second. So we can start raising the bitrate. Let's give you a higher quality. So the next level it might choose in this example is 700 kilobits. Client, once again, issues a request for now the next fragment in time at 2 seconds. This time at 700 kilobits, the server finds the appropriate fragment and delivers it to the client. And so if you have a great connection, it will just continue to ramp up until you get to that top quality. So let's say that we've got a great network. We can support HD. And now we're streaming at 2.4 megabits, 720p. Life is good. And now that background process kicks up to download whatever. Maybe it's a media file. Maybe it's an update. And our network goes down. The bitrate heuristics will continually monitor that situation. And now it says, well, even though I think your network is great, this last download didn't go so well. So it drops down the bitrate. You requested at 1.5 megabits. And then later on, if the conditions improve, you might go up. So this is how we address the last mile by using these two concepts of cacheable delivery and multi-bit rate. And so once we layer the two concepts, really, you allow the client who has the best knowledge about what the playback experience is, make the decisions about what to download and when to download. And you provide the infrastructure to make sure that that gets there as quickly as possible. And the client really has the intelligence. And so it powers this experience by downloading the right bits at the right time. So smooth streaming, this is the release that we made available as a beta in February and that we plan to release in the second quarter of this year, is really about adapting the bitrate in real time in response to conditions. It's about being able to give your users that playback experience that starts instantly, does not stop, and about being able to leverage cacheable HTTP, a cache in between that knows nothing about media, to get amplification, to get benefit, and to address more users. So next, I'd like to show you guys how this actually works in real life. So we have a server here, and this is the player that Scott Guthrie demoed in his keynote. And this player allows us to basically simulate changes in conditions. So because this connection is great right now, it started downloading at the highest bitrate that's available. We can say, let's simulate a drop in network bandwidth and seek to some point. And now it's going to, what you can see here is that it has an indication of the bitrate it is downloading at. It'll tell us actually exactly what are the decisions the bitrate heuristics are making at the moment. And it will plot on a graph the history of how that evolves over time. So if we do another seek, we can see once again that it's going to respond by getting us the content quickly and then sharpening, and you can see that in the text. So next, I'd like to show you guys how all this works in terms of the actual request flow. The first is that the client is going to request a manifest. A manifest, let me collapse all of this extraneous information here, not that much extraneous information. A manifest is really about telling the client what is available. Here are the bit rates that you can get, and here are the fragments that are available at each bit rate. So in this case, it's telling us that you have a video track and an audio track, and here's how you request them. And so then, for each video track, it will then tell us what are the bit rates or quality levels available. So in this case, you can see we've got one at 300 kilobytes at the bottom, and we've got about 2.4 megs at the top and 6 layers in between. And the client is, having downloaded this manifest, is just going to use this data here that's contained to make requests. So what I'm going to do is I'm going to copy this path and download a fragment. So ISM is the extension for a file that describes the smooth streaming presentation, and it tells the server where to basically get in the file system, where to get each piece. And so in this case, the presentation is called bigbuckbunny.ism. And then from there, the client request is structured as follows. The first thing you're going to say is, at what bitrate am I downloading this content? So in this case, we have the quality levels parameter on the URL. So I'm going to fill in one of the bit rates that I know about. In this case, let's think about the way we started. So this is 300,000. And then the next piece is the track. What do I want to download? Do I want to download video? Do I want to download audio? Now, in some cases, you can actually use this as an abstraction layer. What you can do is you can add commentary or an alternate angle or a translation. And you can add it after the presentation has already been encoded. So instead of just video or audio, you might see a track name like alternate angle. Or you might see a track name like give me this audio in Chinese or give me the director's commentary. And then after that, after we've specified the track, in this case just video, we're going to specify the start time. Let's start the presentation from the very beginning. 0, and there's our fragment. And so it comes back as a file. If you looked at its MIME type, it would be MP4, and the first fragment is 71.2 kilobytes in length. So that is basically how smooth streaming works at a technical level. The client makes requests like this. It uses bitrate heuristics to figure out what it should be requesting next, and the server responds to those requests by delivering files from the file system. If we were to go look at how this presentation is actually structured, we could come here into the IIS Manager UI. I've selected, once again, the root of my origin server. That's where this content lives. And walk into Smooth Streaming Presentations. And we can see the presentation here on the server. Now, this interface will only show you the presentations that are defined. But we can jump to Content View and see what that actually looks like on the file system. So you have a .ism file. That tells the server, here's a presentation, here's all the other files that constitute that presentation, and how a little bit of metadata in terms of telling the server where to find certain pieces of this data. The next piece is a .ismc. When you requested a manifest, that's what was downloaded. So the encoder has a lot of flexibility in terms of telling the client what it needs to know. And then you will see one file for each bitrate that we have the content encoded at. So let's say that for whatever reason we're not ready to deliver 2.4 megabits just yet. So what we can do here is we can create a metadata-only version of this presentation that will expose a subset of the bit rates. So I'm going to go to Actions and select Clone. I'm going to give it a name. In this case, it's going to be Little Buck Bunny. Select this presentation, edit it, and it shows me all the tracks that are defined in all the bit rates. So I can say, well, for this version of the presentation, for example, the high definition version might be a premium experience that you only give to your subscribers. This version you give away for free as a preview. So we're going to throw out anything that's over 1 megabit. So we've done that, and now we can come back and request this from the server. So we can download our free version here, and you can notice that the available bit rates have gone down. So we've created a metadata-only image without copying any of the media files of what might be given away as a free preview where the HD experience is only for subscribers. Okay. We rolled out the smooth HD preview with Akamai in October. We've taken some early adopters, and they've given us lots of great feedback. Here's some of the things they asked for with smooth streaming. They said, make sure this technology can scale to my growing audience. Now that I've deployed it, what I want to know is I want to know what my users are doing at all times. I want to know, regardless of which server delivered the content, keep in mind that the content can be cached, what the actual sequence of actions was that they took. This is a really important question. If your users are all dropping off after 5 minutes into the video, you want to know that. There may be an issue with the content you can fix to retain them longer. What is the quality of service that they got? I want to make sure that if there's any issues with my delivery, I can optimize those away to make sure everybody gets a great quality of service and retains my audience. And the third question they asked us is, can you do this for live? So I'd like to focus on, for a moment, on just the first problem, which is scale. Let's take a step back and look at how streaming has been done up until now. In a typical traditional streaming network, you will take content from an encoder, you'll send it to your origin server, and then you will try to address a growing audience of clients. In order to do that, you will deploy media edge servers. Now, the key thing about traditional streaming is that it derived no benefit from a cache that did not understand the streaming protocol. So in other words, every link in that chain between my origin and between my client must be a streaming server. I had to effectively deploy a second network to handle the streaming load. Let's contrast this to how HTTP uses today. Once again, taking a step back. The challenge really is about scale. So one example I'd like to highlight is the US presidential inauguration on January 20th. All across the web, we set records of viewership, of bandwidth, of streams delivered. But yet many users got a terrible experience. People got stuttering, people got lack of audio, many people were simply put into waiting rooms. There's some great analyses of the web today, so this is one link that if you go look at the deck later, it will highlight. But really, most people will look at that as a failure of scale, not a failure of design. We had a reasonably well-designed protocol and communication. We just didn't have the capacity to handle the user load. Let's contrast this, once again, taking a step back, not necessarily media, but just how HTTP works. So you have an origin server. Your origin server keeps an authoritative copy of the content. And you will typically use distribution servers. They're known by alternate names sometimes. A distribution server is a server that is placed typically fairly close to the user. So if you are looking at a remote location, chances are there's a distribution server close to you. Streaming an event from Las Vegas worldwide, you might have a distribution server in Shanghai to handle the load from China. And in front of those distribution servers are edge servers. Edge servers are very lightweight. They typically cache a very small amount of content. They look at the traffic that has come in and cache the most popular things. And so once something else becomes the most popular, because they have a limited cache, the less popular content or yesterday's popular content just drops off, and they basically try to do as good of a job as they can, given their disk space, based on load from the users. In other words, what you don't need to do is you don't need to tell your HTTP infrastructure, here's the content I would like you to cache. The users make the requests. The edge server says, do I have a copy? No. OK, great. I'm going to ask the distribution server. The distribution server does the same thing. Do I have a copy? No. I'm going to ask the origin server, and I'm going to cache it. So these are very self-correcting networks. And the other thing I'd like to highlight about them is that they're massive. There's lots of HTTP caches in the world. If you go to Smooth HD, Akamai, I believe, quotes 36,000 of them in their HTTP network. But even whether you are a CDN or aren't a CDN or using one or not using one, there's many places where HTTP can help you. So very often, these caches will live in your internet service provider. These caches may live in your enterprise. So even if you're just starting out, HTTP caching provides immediate benefit. What I'd like to show is edge caching done with IIS. Now, I want to highlight that for this solution, what does the edge caching doesn't really matter. You could have an edge cache that doesn't understand anything about streaming, but I would just like to highlight the capability we've made available in the beta announced yesterday. We're going to use a feature of IIS called application request routing. And so we're going to have an edge server that's between our origin server and the client. And then, because now the traffic can come from multiple places, we need to be able to track the users. And we need to be able to track where they have gone and what they did and how good was their experience. So we're going to take that client data amassed on this PC you see on the right-hand side and send it to yet another server. And what this server does is it collects logs. So regardless of whether your content came from the origin server, from the edge server, from your browser cache, it doesn't matter. The client reports the experience back to the server. Now, of course, and you will actually see this today, you can combine these various roles into one server. So without further ado, let's take a look at what this looks like actually on the server itself. So for the sake of simplicity, instead of having 3 separate servers, I've defined 3 sites on the same server that will act as my origin, as my edge, and as my log collection point. And the way that I differentiate between them is origin server runs over port 80. The edge server runs over a separate port. So if I make requests to port 8008, that edge server site will handle them. It will route the traffic to the origin server. So let's take a look at what actually powers this edge cache. We have a feature in IIS called Application Request Routing, and a beta was made available just yesterday. And so I'm going to select the server level and take a look at how my caches are configured. So I go into Application Request Routing Cache, and I've defined a cache location. So in this case, it's a physical location on disk. I get to say how big it is. So don't exhaust my disk just caching things. So cache, in this case, I've given it 2 gigabytes, which is pretty small, right? Do the best job you can with 2 gigabytes. Cache the most popular content. And we have some management. So in this case, I can, for example, invalidate all the objects in my cache. And now if I look at this location, C cache here, we can see that it's empty. OK. So now in order to be able to highlight the relationships, I've set up a really simple page here that identifies which server the content is coming from. So it's just hello.html off of the server. So if I request smooth, smooth in this case is my origin server. It's the default port 80 binding. It's going to say, yeah, OK, you're talking to the origin server. I can do the same thing for my edge server. So in this case, I've asked port 8008, which is my edge server in this case, and it says, yeah, you're talking to the edge server. And now let's take a look at the routing rules, at what allows the server to deliver content it doesn't have. So we can come back over here to the IIS UI. We can select the edge cache, and let's take a look at the content. So we can expand this, and there's no directories. All it has is it has a configuration file, and it has this hello.html. And so what I've defined is I've defined a rule that says there's a part of the URL space that really doesn't belong to you. When you get a request for that URL space, cache the traffic and route it to the origin server. And the way that looks is we come back to Features View. We open up URL Rewriter. URL Rewrite is another extension of IIS that powers this experience. So it allows us to actually configure some very complex rules based on, I'm going to open the edge caching rule here. It allows us to configure some very complex rules based on exactly what type of request we want to have. So in this case, what this pattern says, in a nutshell, is anything that starts with edge cache, route to the origin. So I've created a directory that doesn't exist. When somebody makes a request against this directory, pick up that request and route it to the origin. So I can come back to this site now, and I can say edge cache/hello. So in this case, it says you're talking to the origin server, because the edge server has taken that request and routed it. And after I've done that, I can actually see this object in my cache directory. So I've come back to the place in the file system, and there's my hello.html. So we can do this for an HTML file. We can do this for a JPEG. When we talked about smooth streaming, we talked about the requests looking just like any other HTTP traffic to the manifest. So we can do this. In this case, what you see is edge cache, and we've done the same manifest URL we looked at before. So it's happy to cache the manifest. Or how about a fragment? So it delivers the fragment, or, of course, your whole experience. So in this case, what you have is you have smooth streaming being powered by edge caching. So I wanted to highlight the edge caching story we've made available. You can use the existing caches you have today if you have a different type of server. But I'd like to set some context around where we would like to go with this. So we've created an edge cache. It's a great software option. There's hardware options. Sometimes you get an appliance It just sits in your data center. Taking a step back, where are we going with all this? So we've started by looking at an HTTP network, and it uses passive caching based on client requests. With smooth streaming, what you'd basically do is you just add an origin server. And having added just the one server, immediately your media delivery lights up because you get the benefit from all of those edge caches that have already been deployed. So I have added only one server. And all of these caches know nothing about smooth streaming. They just do HTTP. Now, it turns out that if you do know something about smooth streaming, you can actually do better. You can take steps to cache HTTP traffic and to optimize the delivery. So what we can do is we can strategically replace a subset of our caches, not all, just a few, with servers that can both cache HTTP traffic and can optimize smooth streaming delivery. So I've not added to the network. I've replaced a server with now a server that has the same capability plus a few more. And so we can do the same thing at the edge to light up delivery. So for those scenarios where that is really important, the optimized delivery, you can add just a few servers throughout your network in order to be able to scale up. But the other thing I'd like to highlight is coming back to the fact that you need just one server to get started. So if you are not running a network with thousands and thousands of servers in it, this still applies to you. You can add just one server, and you can add edge caches with whatever you're comfortable with to get benefit. So this brings us to the 3 challenges we asked our customers gave to us as feedback after we unrolled smooth streaming. The first, of course, was scale. The second was, how do I track my users? And the third was, how do I monetize? And to that end, we've made a beta available yesterday. This is the IIS Media Services 3.0 beta that has the 3 features. Live smooth streaming, pretty self-explanatory. We basically do the same cacheable HTTP delivery and the same user experience, but for live events. Advanced logging. Advanced logging is the feature that allows you to power your log collection. And what advanced logging will do, as we'll see in a moment, is integration in real time, so that as your data is coming in, you have the opportunity to inject a component in the pipeline. And what it does is it takes that data in real time and takes action on it. That may be monitoring. If what the data comes back to me says is that I have a quality of service issue, I may want a real-time alert to go fix it. Also, I may want to be able to use an existing analytics provider. So in this case, it's great for me to have the data, but I want to be able to take that data and ship it to the analytics provider so that I can get the same types of reporting I'm used to on top of my data. And finally, edge caching, and these are the 3 tiers, the 3 types of servers we think about, are origin, distribution, and edge. So I would like to briefly highlight advanced logging and how it can help with monetization. So we had 3 sites here that are simulating 3 different servers. We can go to the log collection server. And in this case, we're going to navigate to advanced logging. And advanced logging allows you to define different profiles. So you may want to generate different types of logs for different types of information. If you want to generate a log about what your server is doing, that's what you see as the first entry. In this case, we've created a separate profile that generates log about what is coming back from my clients and logs it in the form that's most natural to that. So when we open up this log definition, we can see a couple of interesting things. The first is, if we scroll down to the fields here, it only logs the fields that are relevant to the client. So this is the user experience data coming back. It says to us things like, in this case, this is a pretty trivial set, but what is the ID of their player? In other words, you can do session tracking. I don't just care about this particular client. I want to be able to correlate that experience data to a particular session. I want to be able to correlate that session to a particular piece of content. Similarly, we also have the ability to publish real-time events. So if we enable publish real-time events, we can have another component in the pipeline. And what that component does is either A, alerts us in real time. You've got a quality of service issue, go fix it. Or B, takes those real-time events and delivers them to an analytics provider that we already use, know, and love. In Alex Zambelli's overview session on the media ecosystem, he identified basically 3 steps that make up the experience. We've spent a lot of time today focusing on the step on the right, on delivering your content, and all the servers and all the infrastructure that you need to do that. In Alex's session and in James' session, James Clark presented a session on how to create the experience, how to create your application. That has already happened, but you can go watch it online. It will show you how to create the application. But I'd like to spend a moment focusing upon the 3rd thing you really need to do to get that great experience, which is encoding. Now, after Scott demoed live smooth streaming, a lot of the buzz that came back to us was, are they really doing live? Well, I am very pleased to have Inlet Technologies here to, you might say, to pull back the curtain on what it is that we're doing. Okay, well, John, it's just a figure of speech. No, it's fine now that you've done it. In all seriousness, it's my pleasure to welcome John Bishop, Senior Vice President from Inlet Technologies.
Thanks, John. So I'm going to talk about the encoding piece. So quick show of hands, who here has done a live streaming event? Okay, so a few of you out there. Quickly, topology. When you look at a live streaming event, how do things work in a traditional event? You've got a couple components. You've got your source, your camera. It could be a satellite feed. It could be someone actually on set. Step 2 is the encoder. Then, of course, the last step is the server, the distribution point. This is your traditional topology for all streaming events: source, encoder, server. In this model, you've got a level of management that has to happen, but it's very passive. Your setup is typically your source is feeding your encoder. Your encoder is putting out the different bit rates that you've seen. So as John was talking about earlier, you might have a premium experience, kind of a mid-range broadband experience, then, heaven forbid, a dial-up experience. When we look at live smooth streaming and the benefits of that, and quite frankly, we think adaptive streaming and smooth streaming is the killer app of video, because there is no common definition for broadband. People have a different level of experience for everything. And so the very nature of smooth streaming is to give the instant best quality of experience. And through that, the first thing that it achieves is you don't get that annoying little buffering window anymore, content rebuffering. That's when you lose stickiness. That's the #1 way to lose stickiness in content. Let there be a disruption of service. So we get rid of that with the smooth streaming model. The other thing I mentioned was you get this dramatic increase in quality of experience. The user's always getting the instantaneous, in John's language from earlier, the instantaneous best fragment. So before he showed you going from 300K to 700K up to 2.5 megabits per second. That changes on a variable basis, and it changes every few seconds. The other thing, and one of my personal favorites, is we've all seen the dialogue where you come to a web page and you've got the opportunity to see small, medium, large. And you have to select what video experience do you want to watch. Well, with smooth streaming, it's now the watch now kind of link concept. The intelligence is handled between the server and the client. So you put one link out there. You no longer publish 4 or 5 links for different experiences. The user doesn't have to know what broadband service they subscribe to. They don't have to know what kind of PC capacity they have. All that's the under-the-hood intelligence that John's talked about on the IIS side. So no more high, medium, and low. The other piece, and we'll talk about this in the coming slides, is you can leverage your existing infrastructure. So the traditional infrastructure that you've invested in, you can still leverage that for smooth streaming. There's just some minor changes. And from an end user perspective, it's transparent. They never see anything different other than a better quality of experience and no buffering, which is what we want them to see at the end of the day anyway. So on the live challenges, first and foremost, it's live. And in that respect, every frame counts. Think back to the Olympics last year. Michael Phelps touching the wall there at the end. You miss one frame of video, you miss that touch on the wall. You can't miss frames. It happens one time. When you start looking at the internet and the open distribution model of going over the internet, there's not this one size fits all. That's the very modality of why smooth streaming is out there. It's addressing a variety of different bit rates, a variety of different experiences. So you've got one source going out to a lot of different outputs. So visually that's represented in You might have an HD experience at 3 megabits per second, and then you matriculate down to a 200 kilobit per second to kind of represent a low-end speed. That could go all the way down to broadband. It's fairly random on how the actual breakdown goes there. But you've got one source going out to a variety of outputs. Again, the goal here is to give the best experience for your end users. Well, it becomes complicated on the smooth streaming side because you can't have one single encoder handle all these levels. You can't have one encoder producing your HD streams, your SD streams, your mobile streams, et cetera, et cetera. So now you've got one source distributed out to multiple encoders. Well, what this creates is a timing issue. John talked about earlier how different fragments are sent to the player on a request basis every 2 seconds. Well, you need to make sure that you've got time alignment on those 2-second boundary conditions. You've got to make sure when the request comes in and say, I'm going to go from that 700 kilobit stream up to that 1.2 megabit per second stream, that the audio and video stay in sync. You don't want the video to be leading in one segment and behind in another, or audio to be off. You've got to make sure you have that synchronization. And then when you look at how synchronization relates back to redundancy, this is probably one of the biggest challenges when you look at how do you manage a dynamic experience. If an encoder goes down or a stream goes down, and we've all kind of seen the traditional bars come up on the television experiencing technical difficulties. If one of those things happens, how do you actually publish back in new feeds on a common timeline? Because your timing, again, has to remain synchronous. So I showed you this infrastructure picture earlier from before, where you had your traditional infrastructure, where you had source, encoder, server. When you look at live smooth streaming, what changed? You got a slightly larger footprint on the encoder. What is that doing? Again, you've got that one source feeding multiple encoders, putting out multiple quality of experiences, multiple different data rates, multiple different resolutions. You've also got your management control, which was very passive before, where you use for job configuration, has now become active. You've got a lot of management there, and you've got a lot of timing coordination. And when you look at events of scale, the management portion is probably the most critical portion. When you're scaling out an event, you use your central management first to come in, configure your job. By your job, how many experiences are you going to put out there? Are you going to go from HD down to mobile? Once you get that configured, how are you going to schedule machines? How are you going to provision those machines? All these are fairly tactical tasks. Getting beyond that, the way smooth streaming works is there's the notion of a manifest is generated. A manifest is what John was showing earlier. It's a stream descriptor. It says, server, expect 8 different bit rates to come to you. Expect that 3 megabit down to 200 kilobit segmentation, and maybe the stair steps are every couple hundred kilobits. So the manifest describes what the server is getting ready to get. There's a notion of heartbeat for redundancy. What happens if a machine goes down? How do you get back in line with a backup server? How do those redundant servers come back online and give the same common time feed? So if a server goes down, how do you feed in new content, but it adopts the previous timing model that you've already established? And again, that goes over to failover, both from an encoder perspective, but also from an origin server perspective. How do we manage that? So when we look at where do things fit quickly in the ecosystem, you've got a management layer at the top part. So from an implementation perspective, the only thing you really have to care about is you have 2 components. You've got some kind of encoder management console, and you've got an IIS server. John's talked about the IIS side. On our side, we make the Spinnaker management console. Underneath that, that's where your encoders go. That's where your Spinnaker server goes that manages your manifest files and your redundancy and your scheduling and your failover. And then underneath that, you've got all the little features. That's where things like audio, video ingest are happening, audio, video encoding, all the little tactical stages are happening down there at the bottom. We can drill that back down to a much more simplistic approach. If you look at the single encode model, the diagrams I've shown prior to this have been more for an Olympic type setup where you've got lots of different experiences going out there. You're really trying to grow an audience. But smooth streaming is not about just a larger footprint. It can be done in one encoder. You can have one source going out to multiple encoders. One source going to a single encoder, pardon me. And the encoder is actually delivering multiple quality of experiences. So in this case, I've got 4 encodes coming off one encoder. You've got encode A, B, C, and D. Each one of those is generating a unique fragmented stream, which John talked about earlier, and unique manifest that describes what the stream is it's delivering. So this is the simplistic approach. What we're going to show you today, and to kind of prove the point that it is actually live, we've got set up a source and a series of encoders. We're showing the example where you've got one source going out to multiple encoders. Again, you've got to keep time synchronization here, and you've got to make sure that the switching, the stream switching that's going to happen is going to happen exactly at the right time, so you don't have a disruption in service from a quality of experience from an end user perspective. For this demo, this is a quick snapshot from last night doing some demo setup. We have a VTR. We're using a VTR because we can load a tape in there, and we really wanted to challenge the encoders here. Throw some really challenging content. So you'll see some fast motion, high fidelity content coming in. Then we've got our Spinnaker 7000 encoders. These are HD capable, and they'll go HD, web, SD, mobile resolutions, really resolution independent. And then from that, we've got a monitor. I'm up here watching some content on stage, watching a soccer game actually. Out of the VTR, we're simulating what a live camera feed would do, something that we would expect to see at the Olympics, at March Madness that's going on right now. We've got this high-definition serial digital interface, which is outputting 1.5 gigabits per second over a coaxial cable, and that's coming out of my source and coming into the Spinnaker unit. You can see that you've got two Spinnaker units, so I've actually got two outputs on the VTR representing the same common source, both going to different units. And again, Spinnaker's maintaining the time alignment here. These boxes don't have to even start at the same time. They can start seconds apart. They can start the exact same time if you happen to get lucky and click on the button at the exact time. But that's where Spinnaker manages that experience. And then finally, LAN. How are we actually communicating those encoded bits back to the media server? Again, there's three elements. There's the source, which is the VTR, the encoders, that's the Spinnaker unit that's on the bottom, and then the last piece is the server piece, and that's where the LAN has got to pump out the encoded bit streams in all the high, medium, and low varieties out to the IIS server. So with that, I'll throw it back to John. John, if you want to talk about how this is actually going to happen now from the streaming server perspective.
Thanks. So from a server perspective, what you have, and let's ignore these changes. From a server perspective, what you have is you have a set of publishing points that are very similar to the presentations that we had for on-demand smooth streaming. So I've selected the live subdirectory, which is these publishing points are actually files on disk, so I can X-copy them around if I want to. I'm going to open up live streaming publishing points, and in this case, we have one defined. And much like the on-demand where it was ISM, in this case, you have an ISML. And what it does is it provides the same level of abstraction to the client. So the client makes the exact same pattern of requests. Give me a manifest, give me fragments. And that server manages all of that complexity as a publishing point. You might have multiple publishing points to deliver multiple events. So if I had a soccer game going on and a racing event going on, I might have one publishing point for the racing event and one publishing point for the soccer game. I would have encoders posting to each publishing point, and of course, clients consuming it. So we're going to create a publishing point on the fly here, and I'm going to call it sample.isml, welcome to MIX, and I'm going to accept the default settings for the publishing point. In this case, what these checkboxes really mean is make the client first keep an archive. Using that archive, make fragments available to clients. So expose this publishing point to end users. And the final checkbox is expose this publishing point to other servers that may want to syndicate the content. So I'm going to create this publishing point, and the UI is going to show us the state. And at this point, it's basically waiting to be started. So I'm going to walk over to the Actions pane and click Start Publishing Point. And now it's ready for an encoder to connect. In the case of sample.isml, I'm just going to simulate some load on it and refresh this UI. And now you can see that it's started. So I'm ready. I've got content. Now, what we're about to show you actually uses inlet.isml, which we started in advance. And what's happening is that the encoders are posting to inlet.isml. The connection here is HTTP. So it's just using a long-running HTTP post to get that data to the server. And so we can walk over to the client and see what this thing actually looks like. But before we do that, John, let's do this for real. Right? We're going to do a broadcast, so clearly we need a countdown. And we're on the air. All right.
Our scores on a penalty kick to tie things up at 2 apiece. But in the 88th minute, Kim Yankowski sets up Hege Risa for the game-winning goal. The Courage beat the beat, 3-2.
Oh, it was...
88th
We have
minute, Kim
integrated DVR, so we
Yankowski
can just
sets
hit
up
replay.
Hege Risa for the game-winning goal. The Courage beat the...
We can pause it. We can jump back to live.
Late in the opening stanza, Danielle Fotopoulos is taken down in the box. No call, we're scoreless. Lots of fireworks in the second half. The cyber race, Kim Clark gets behind Carolina's defense. She knocks it home, 1-0 Bay.
So, with just those steps, the same great experience we had on the on-demand side being provided for live smooth streaming. Now, in case some of you aren't so lucky as to have a great set of inlet spinnaker encoders, we've provided a way for you to experience live smooth streaming. Just go play with it without necessarily needing a full setup here. So I'll show you what this simulation process I started looks like. In this case, we are releasing a test tool, and this test tool here is called Push Encoder 64, and you basically say, what publishing point do I want to simulate load on, and use an existing on-demand smooth streaming asset to be able to experience this. So in this case, this is Big Buck Bunny. The Big Buck Bunny is available as sample content for free download, so if you go get the bits, there is a link on the IIS.net site where you can get this content, and so we're just running it in a loop. So we can come back to our client here and see what that looks like. So in this case, it's still a live experience. Anyway, it's still a live experience, but being simulated from on-demand content. So it's just a really great way to experience the bits. So we'd like to wrap up by giving you a sense of what the various components are and when they'll be available. Really, our goal is for you guys to try it and give us some feedback. We're really curious to hear what you think. We're really curious to hear how we can make the technology better. Bitrate throttling and web playlists for delivering existing content better was released to web in the 4th quarter of last year. Smooth streaming was betaed in February, will be released in the 2nd quarter of this year, and the live smooth streaming, advanced logging, and edge caching features we discussed are available as a beta as of yesterday, and they will be released. We plan to release them around the 4th quarter of this year. So we've talked about some of the great reasons why you might want to use media and some of the things that the experience can power. And really our goal is to get you guys to try it. You can go to iis.net/media. It will have an overview of the sessions, an overview of the bits. It will have links to download. It will have some walkthroughs to get started. You can get up and running with content using Expression Encoder, and of course, Silverlight to play it back. So I'd like to conclude by putting some of this in perspective. In Alex Zambelli's overview session, we discussed the 3 components that make up of the experience: creating your application, creating your visuals, encoding your content. So we saw one great option for doing it live. You can use Expression Encoder or another solution to encode on-demand assets, and of course delivering the content. And I'd like to highlight some of the other sessions that are available. So this has already happened. James Clark yesterday, and I would encourage you to go look up the video if you're interested, on creating your application and coding your content. Of course, the overview session on how to put all this together. And tomorrow, Nick Brookins from Akamai will be talking about how to deliver ad-funded content using the Silverlight Player application. And just as a logistical note, I would encourage you all to please fill out the surveys in the room. And so I would like to conclude by thanking you for coming here to MIX. We've tried everything in our power to make this a great experience, but I do want to remind you that some things are outside of our control. So please, when you leave this auditorium, remember. Thank you for your time.
Good job. Questions?